So this is how I like to model out a database when I'm trying to make a web app. I'm gonna have my tables, and this just lets me know that this is a one-to-many because there's a user ID here. And if it was a one-to-one, which is weird, I could have an address ID here, and it would let me know that it's a one-to-one. But because there's no address ID there, this is a one-to-many. If I wanted to make a many-to-many, like a group, I would give it a user ID, or I would make a join table. I make a group name. When you have a table like this set up, you can just visualize it really easily. This way, you can have something, because someone was looking at this and wondering about the structure of relations. And this would be a bad thing to look at because it's so long to get just a bird's eye view of your tables and your database. To make everything as concise as possible, you would even just omit the field types and just focus on the column names. You have a table and you have the columns, and that's it. And from the columns, this is actually your most common one-to-many. And it's so easy, you just put the ID of the thing in the many. And you'll just have one ID of the one inside the many. Okay, let's design, which app do we want to design? Let's do one that we didn't do yesterday.
Let's design.
Let's do Instagram.
Instagram? Didn't we do Instagram yesterday?
Yeah.
Oh.
Let's do one we didn't do yesterday, just so it's fresh in everybody's mind.
Blue Apron.
But, wait, wasn't that one of the other ones?
Mm-hmm.
Oh, not out of those, yeah. Like one that nobody has done. Uber.
Yeah.
Okay, we have users. Not every app will have users, and that makes an app way easier, but Uber has users.
Uber does have an address. And it has destination.
It has many addresses.
Yeah. So would destination be separate from address?
Would destination be separate from address? I mean, I feel like yes, but a destination would have an address.
Yes.
Couldn't you create a separate table for like destination and pickup or something like that?
Yeah, like pickup address, destination.
Pickup address, destination. Do you think those can be rolled into one table?
And is destination something you database?
I think in the address table, and we can have a transaction which has a pickup address and a destination address, both of which have constraints of being in your address table.
I concur.
What did you concur with? Sorry.
Okay, so we're going to have a transaction table.
Transaction table. Yeah, I'm going to call it trip.
There you go.
Yes, perhaps transaction isn't the clearest word.
And they all have an ID. We know they have an ID.
Right.
I'm just going to make it easier to look at. We know it has an ID. And it'll have a destination.
Pickup destination.
And a pickup. And these would both be
Stops. There's stops in the middle.
ID stops. If is this an Uber share? Are we limiting stops? They probably limit. Probably have a hard limit on
You
stops.
can only have one stop in the middle, and that's whenever you're doing a one-person ride or just one destination.
All right, let's just have 2 for us, and then we need time.
Yeah.
Okay, timestamp. I'm gonna
And we probably have a many-to-many relationship between trip and user.
many
Distance.
trip and user.
We also need a driver.
Yes, I would have a driver
Oh no, wouldn't that be like separate?
and
Passenger would probably be a many-to-many. If we're having multiple stops, we have multiple passengers.
multiple stops and passengers. Oh my goodness. Do you want to just do
We're
Uber
doing Uber 1.0.
Uber X or whatever?
Uber
sort of
1.0.
we're not right.
Let's do Tinder. That'd be easy.
Tinder.
Yeah.
Okay, so we got the trip table. That I think is the Uber for Tinder. Let's see. We'll have a many-to-many, right? Oh, are we shifting?
Yeah, we are.
Yeah. Okay, let's do Tinder.
So we did Instagram. Tinder.
So
We're just duplicating Instagram.
I think you have something like that, and then you have other users. How does it work? You have your GPS
Matches or something?
Yeah, location.
Location.
Distance.
We're no longer in an Uber, right?
We're doing Tinder.
Distance. I would not store in the database. That's something you calculate on the fly.
So would you have like potential matches and then matches would be 2 different tables?
You don't really have addresses in Tinder, do you? I'm sorry, I don't.
I don't think you do.
That sounds really scary if you do.
I've actually never used it, so maybe it's.
So I would say you probably have a match list table that can
Match list. Okay.
which is a user to which starts out as a user to user crossover.
A user
It also
user
has a
table.
match.
So it'll have a user 1 and a user 2, right? Does user we can't call it a user ID for both of them. So I'm gonna call it.
Match ID.
Match ID.
Matcher, matchy.
Oh, it would have an ID. Matcher, matchy.
It's not even really that clear, actually.
It's not that clear.
Yeah.
I mean, it doesn't matter necessarily. User 1 and user 2 would be just as descriptive, right? Because you know it's
Okay.
just 2 people, unless there's like 3-way dates or something. I don't
It's
know.
not. Okay, user.
That's that feature we're gonna have.
Or is that a different app?
No, it's Tinder X.
User 1 and user 2. And we'll call these match.
And maybe in that match table, we're extending it to say, does user 1 matches user 2 and user 2 matches user 1 as booleans?
Okay, so we have user.
Yes.
Okay, with that data, I think.
So from a database standpoint, though, is that the kind of thing you would be really logging in the database, or is that something that would be predetermined from your, your functions in the database? Really, I mean, what's important to hold on to?
What's
Or am I
important to hold on
Or am I
to?
not thinking of databases correctly? 'Cause this
Database,
is-
you're thinking of it correctly, and
this
that's the
information is-
question that you have to run through in your head when you design an app. When you design a database, what data do you want to hold on to, and what can be calculated on the fly?
Like messages.
Messages?
Messages from the users. Oh yeah.
You want
so that
Meet
because.
I agree with that. I think the user one likes the Booleans. I don't think that would be something that's in data. I think that's something
Not
that
in data.
would be solved because I mean
Well,
the matches are.
Because you have to, the way to design everything, you have to hold on to it until both is when, because otherwise.
They both have to swipe.
Well,
That's
that's
a match.
right?
Would that not be? And I'm not trying to get into the weeds of it, but would that not be solved like by a function, and then the match table is then populated?
It still needs to be stored.
You still need this data
Whenever one
to.
person.
And think of it this way too. In order to determine that, you'd have to look through the table twice, right? You would have to look through to see what user has a match with that specific user. So you'd have to roll over the table twice. Or you can add a singular column that, says that already. So when you have millions of users, it might be very expensive to go over the table twice.
Mm-hmm.
Tinder 1.0.
I mean, yeah, we're not developing as it is.
You
But
would need another data set for those that match, not really match one, because matches you're taking, if it's false, then the other one is canceled out no matter what, unless it's both true. Then you would start a table with the matches.
This
Because
started taking with the matches.
Because you're going to match in the
Mhm.
first and match, but then you actually have those that actually matched. Because you're
A separate table. I like that where we have matched and matching.
or matches. Yeah, matching. Yeah.
G is and match it is.
And this is all we need. And over here, we need the.
I think the match would store the likes and dislikes, and then the matching would be the ones that would actually build what they both liked. Because then you're actually storing your matches, where beforehand you're just telling which ones you want to match with. So I think you're
Yeah, I like
likes,
this
and then
better.
Matching is the ones where they actually likes.
Don't you need a database for pictures too?
Pictures is its own thing. I would just pretend it's a text or
I would
something.
say store it as a URL where the picture is.
Profile.
Or you can store the
Users,
link
data, profile.
in a text. You'd have to get a server to store the photos, because there's free servers out there everywhere for code if you just want to store code, because it's just some text. But it starts getting expensive when you want to store photos, so you have to start paying and use servers, or I guess make your own. What would you need?
You still have to add a column though to your user.
Ah.
To your user table for your photo, where you
Profile.
would store a blob or a URL.
Photo, and it would be a blob, text. I think you can.
I think they call it byte A.
Borders, you can store images and text. It's a photo.
Yeah, they
I'll
say
worry about
And what about a blurb?
that for now.
Right,
Blurb.
you have a blurb.
A blurb.
Yeah, whatever.
that Postgres can't do blobs. They do byte A is what they're called.
Right. A. Okay.
What if the user's blocked, for example? That's a concern of Tinder.
The user is blocked.
Yeah.
Yeah, block status maybe.
Maybe. Wouldn't that be under matching?
You gotta keep
Matching.
Yeah.
Oh yeah.
Then you have your memberships. Your membership where you're storing.
It's getting confusing. So that's the. For right now, it's very good to think about efficiency and things like that. That's great, and if you're at that level to where you understand everything and you're making it more efficient, that's great. But before you understand everything, you just want to make it as simple as possible. So sacrifice performance. But for right now, in the school setting,
Yeah, we're just getting MPT,
Simplicity.
right?
We're
Yes.
not making Tinder right now. Yeah, we're gonna start.
I need to make money. I want to make.
make money.
Well, I'm making Tinder. I'm the only one that's on the search.
Call it Tinder instead.
So what should we do now? It's 9:46. You might want to work on SQL queries. Hint, hint.
Yeah.
And oh, you can't see this. So you definitely want to get SQL basics down and writing some SQL statements as well. And you want SQL queries. Has anyone done SQL Zoo yet?
Not yet.
SQL Zoo is awesome for pairing. I think it would be like kind of torture to do it by yourself because you get stuck for a long time. But if you're doing it with someone, whether not necessarily on the same computer, but doing it at the same time as someone, and you say, "Oh, have you done number 9 yet?" And they're like, "Oh, I got stuck on that one too," and it's just this thing, and it's just one SQL statement that you need to get past, and you can keep going. That's fun. Have people tried this yet? The queries?
Yes.
Yeah.
6 right now.
Okay.
6 words. Putting all the dictionaries together to get class.
I think we can call it a day for today. And at 1, I'll do a breakout session for people who still are iffy about the relationships. We can go through in a smaller setting.